researcher, and he's always supported us. So I thank you. We're doing that every year, and I'm absolutely positive that this is going to be an amazing talk. So without further ado, Aditya Sood.
I make it really easy. Only shame and not.
We can wait for 30 minutes, 30 seconds? Or if you guys, I think we're good to go. All right. Right. Yeah, let's finish the finishing the. Yeah. Okay, yeah, we can go down. All right. Thanks, Ron. So let's get it started. If we are all set, and let's have a great run through for 45 minutes and have a deep understanding of what we are going to talk about today. So today, the purpose of this talk is to focus on the data. Data is not about single state of data or distributed way, the way data is transacting, not talk about like technology, but we are going to focus mostly on what is the importance of data in the cybersecurity space, primarily the attacks that are happening. So before moving further, I want to lay a little disclaimer. The idea behind this research is to highlight what exactly going in the underground cyber world and how exactly the cyber attacks are happening in real time. So the purpose is to understand some of the things we might not have seen in the wild, but we have, talked too much about it, this malware, that malware. But what exactly is happening behind the bars? So all the research that we are going to focus today is primarily for education purposes. There is no relevance to like a company or any organization or any kind of those sort of things. The purpose here is only educating ourselves to understand what it is all about. A brief background of mine. So the idea is to highlight what we are going to present today. We know what we are talking and why we are sharing this information. Been in this field for the last 15, 16 years, drafted 2 books. So you can check the background and get a feel about it. So what is the agenda today? So today we're gonna look into the data perspective. We're gonna look into the exponential rise in security breaches. But then we're gonna talk about the underground cyberspace paradigm. We wanna see how attackers are utilizing underground cyberspace for selling data that they have stolen or exfiltrated. We will look into dissecting the advanced threats. We'll take in the real world use case studies of InfoStealer, Locky Botnet, Locky Rat, cloudifying infections, and all those sort of things. But the main purpose behind this is to highlight how different and variations of these kind of cyber attacks are happening in the wild and how they are exfiltrating data. So you will see that from standard systems to the cloud to the other set, how this thing is happening. So let's take a look into the data perspective. Why we are talking about data today, right? So if you look at the way technologies are advancing day by day, the way devices are interconnected, and the way transactions are happening, which means that, earlier, technologies were there, but not that advanced because, there was standard way of infrastructure was designed. But right now, things are different. Mobility is the key. Devices, everything has to stay connected. The world of applications. That's a big problem also. Of course, it has revolutionized our life, but at the same time, it has given rise to different attack surfaces as well, which we'll go through during the course of this talk. But this is the problem. And the idea behind it is who controls the data, who owns the data is going to hold the keys to the kingdom. Brief layout of how the biggest data breaches are happening in last couple of years. So you can talk about, we started from thousands of dollars of cost, we had transformed it to millions, and now we're talking about billions. And down the lanes is going to be much more to that, which entails to the problem that it is a big issue and we need to handle it efficiently. The stats highlighted here is actually the reflection of the real world scenario, how exactly these things are happening and why it is important to look into. Before starting further, I actually want to highlight understanding about the cyberspace paradigm. How underground cybersecurity has been going on and basically how attackers are transforming the internet into the underground cyberspace. The very first screenshot you highlight here is that the advertisement in the underground cyberspace, talking about one of the biggest organizations that got compromised. So let's say I don't want to hold it what it was, it's basically the BAE systems. So you can clearly see that the stolen data is being sold in the underground community. If we go back to the purpose, we really need to look into it's still the data, right? Why they are selling data? They should have compromised the systems to do it for fun. But then the question is about today, most of cyber attacks are going after basically monetary benefits. And that is the most important part. Another one that you look into is recently happening, that is in the November, is about another biggest corporation in the South Asia and talking about the Tata Power. Their systems got compromised and the way data is being handled and sold in the underground cyber community is just one to worth to look into. But these all things are happening in the real world. You and me might not be able to see it in the wild, but this is all happening. So you can see how much impact it's going to cause cost to the organizations. Similarly, if you look into this one, the crimeware products, we did in 2012, we wrote a very detailed paper on crimeware as a service where we talk about variety of services that attackers are selling. And these have gone advanced with the passage of time. With the advent of cloud infrastructure, technologies, things have changed a lot. But if you look at into it, like apart from credit cards, stolen data, and all those, these are also giving you a service of compromised CNC panels, which is basically relying on malware hosted on the command and control on a compromised infrastructure. So you can just go ahead and one can buy that. So look at the way this thing has been productized, right? And this is all happening in front of our eyes, but just we can't see it. If you look at this specific one, it's all about selling exfiltrated data. Look at the way these people are selling the data. My question again in this case is that if you look at the context of this research, the focus is on why data, right? As I mentioned earlier, I will reiterate it again during the course of this talk. Who owns the data going to own everything on the internet? And this is just only one part of it, just a few samples we are sharing here. But it's the tip of the iceberg. There's a much more to it. So let's take a look into the advanced threats. So right now, what we have gone through is looking into how the underground cyberspace look like, what's being sold there, how big organizations' data are being sold there as well. So look into the advanced malicious code. We can also call them as a digital weapons these days as well. We talk about ransomware. We talk about information stealers, remote administration toolkits, payload downloaders, crypto miners, service booters, scanners and exploit frameworks, and communication hijackers. So every single variation of this malicious code is deadly in its own context, the way it is being used. So we call it as a digital weapons these days because that's why the attackers are going after utilizing these malware or malicious code is entirely off the fly. And that is a problem. And what we really need to do, we'll look deep down into the course of this research. So just for a basic overview, when we talk about advanced threats, right, we talk about malicious codes, what kind of characteristics these have. So if I give a very simple one, the malicious code that has the capability to subvert the integrity of the system where it is run, whether it's your operating system, whether it's a node or whether it's a VMware containers, they have the capability to abuse the inherent infrastructure and of course the systems as well. So for that, any characteristics that they do for masquerading, tampering, hijacking, subverting, and many more. The idea here is to transform the system into such a state that it can be abused for nefarious purposes. And threat actors, we can talk about attackers, employees that are sometimes they make mistakes, erroneous employees, which say nation state actors and cyber criminals. So at this point of time, what we have gone through is looking into the little bit idea about underground cyberspace paradigm, what advanced threats are, and why we are transforming them into a digital weapons. What attackers are actually going after them. So just to look into the simple life cycle, so to get a feel of it, how infections are spread before we go a deep dive into the real world case studies. Of course, you visit some website or by phishing. So whenever you call as a phishing, so there is a variety of different attacks into it. So there can be a tier one, a phishing which simply redirects you to go to some web page which asks, conduct some social engineering trickery and then ask you to give the credentials, right? Tier two is basically that phishing attacks that are happening to conduct drive-by download attacks, right? You click the link, go to some web page, your system gets exploited by browser, and then you got infected. Tier three basically falls into the category of phishing attacks that are happening, having attachment in emails. So you open the email, you get an attachment, you open it, and you just got infected. The whole purpose is like we're to actually control the system. It maybe could be a part of controlling or compromising one system or making it a part of a botnet. But that's where these things are happening. And the digital weapons, the malicious code that is used to do that is the key here. And once your system is infected and compromised, different things can be done in it. So let's talk about info stealer in action. So this is one of the recent one that came across. So we did a pretty good study on that. It is called as a black dot info stealer. It's of Russian origin. It conducted distributed attack in the way it is spread all across on the internet, various countries and all that, which we'll take a look into, and then we'll get a feel about it. If you look into this one, so if you look at the blue picture here, this actually highlights the command and control panel, how it looks like. So if you get into the infrastructure and you open it in a browser, if you're lucky to get the IP address or a domain where it's being hosted, so you will see something like that. So what we did in part of this research, we were able to find some vulnerability into it. And then we actually exploited that one or the other way. It maybe could be a part of configuration issue, or maybe some sort of a problem in the web framework. So when we did that, so if you look at this particular picture, in this case, you can see the type of data being downloaded. So you can look at the idea, it was from Sweden, Switzerland, United Kingdom, States, and many more countries. And it was all hosted on a one specific command and control. So you could have imagined how many command and control panels are being running in the wild, right? So if you look into the other part, we are just analyzing the state of stolen data in this case. If you look at it in this one, it's highlighting the passwords that are being stolen from the end users. The point is not about the passwords here. The point is about like the different applications that users are using, and they are able to actually extract the credentials for those apps. For example, it involves Uber, it involves Delta, it involves Amazon, Yahoo, Roku, and many more, right? So a single user or multiple users utilizing these applications, their accounts are compromised. So as a part of the testing, when you try the control manner and for threat intelligence, it all works. And it doesn't include only application, it also includes their routers as well. And if you look at the other one here, it actually talks about the data structure and the layout, which actually highlights how efficiently they are storing data. So attackers are just not simply going after, okay, I'm going to extract that data, I'm going to dump it. They are dumping it in a very specific way. Because if you remember, in our earlier slides, we talk about they need to sell them. They cannot sell the data that is crappy in nature. They really need to clean the data. They really need to sell it in a way that can be consumed by the other adversaries. And that's what is happening right now. Another example is that it's not about the credentials only, it's about your crypto wallet information. It's also about your session information. And to nonetheless, it's also about your messengers, like whether you're using Discord, you're using Telegram and all that, they steal it all. And you can just imagine, it's not about, as I said, credentials, which has already gone out of the way, but it's all about the other ways. So the attack surface could not be only the credentials because they're going to use them, but also your session identifiers, also the Telegram records, and also for like Discord data and all that. But it's all happening in front of us, and we analyze this data in and out. So if you look at this screenshot, this is taken from one of the compromised systems in the United Kingdom. So these guys are not only holding to the data sets, which we have discussed, but they are also kind of going after, we're not going to leave any single thing in the compromised system. Anytime user is maneuvering in the system, making some calls or doing some activity, they capture the screenshots as well. So in this case, they are not only able to get all the other information, but also the other system level information or kind of software that are being installed are basically also analyzing the behavior of the end user. So that exactly highlights, when these kind of distributed attacks happen as a part of info stealer, the kind of data that is extracting out. So the importance of data goes really, really high in this case as well. So now we looked into the info stealer. Let's take a little bit look into the Locky botnet, right? So this botnet is being deployed a lot these days, highly efficient, and doing some sort of nefarious activities on the internet as well. So when I say a botnet, thousands of machines are compromised running Locky bot, all connected back to command and control panel. They have like HTTP-based command and control panel. So you can, if you get the identity, you get the domain name, IP address, and you can, get to it. But important part in this case is that it's going on for a couple of years, but it's still residing in the context of security and threat intelligence, the reuse of the botnet code, right? So somebody built Addis bot, which was like heavily used earlier as well, and then they transformed some components of into a very efficient one, transforming it where the earlier bot was detected, but they don't want to get detected this time, so they create Addis bot. And that's how you advance, right? That's how these attackers advance in the building, I would say, digital weapons. So if you look at this screenshot, it also gives you the login panel for the Locky botnet, command and control panel. But you look at the other kind of, modules that it supports, from reconnect, disconnect, screenshot, start the logger, disable, stop, and all those kind of things. So it actually highlights the kind of operation that attacker can perform right away in the compromised system. Similarly, if you look into this screenshot here, it actually talks about the operation, basically the commands that they store, like they can shut down the system, they can, fetch more binaries from the internet and, install multiple malware onto the system as well. So that is most important part of it, because then they can use your system, which is compromised, to launch pad, to make it a launch pad that you can trigger more attacks on the top of it. So it doesn't mean that if the system is compromised, it's a part of the botnet, it just only holds some specific type of purpose. No, all the bots can be used to launch pad, act as a launch pad, sorry, in that case to trigger more infections. So we look into that botnet play, how it looks like and all that. Right now, we are kind of looking into the remote administration toolkit. This is a Locky rat. This is not a Locky bot. So why I want to talk about this, that because this rat is being heavily used to infect government systems all across the globe, right? So we have tranches of information, but I'll probably show you a couple of snapshots of that so that you get an idea where these actually rats penetrate and what kind of systems they kind of compromise in this case. So let's take a look at it, how it looks like. So again, a command and control panel for the Locky rat. You can clearly see how it looks like. So they can also change the protocol sometimes. They could have an HTTP-based command and control panel, or they can use custom protocol, like they enhance the telnet protocol to actually use it for command and control communication. But here is another screenshot that I highlight how this Locky rat is constructed. So it's a part of the source code, so you can see client and the server. So rats also being designed in such a way that you can use it as a part of a SOX proxy, or you can also be a reverse proxy. It all depends how your network controls are being configured in an organization and how they need to bypass it. So as I mentioned earlier, that when they compromise the system and bot is running, which has the capability to download more malware into the systems, so attackers use that capability to download remote administration toolkits once they decide this system is critical. And then they completely own it and do things like that. And I'll show you the kind of data these guys are picking out of the government systems that are compromised. Yeah. So again, I put like a confidential tag, but it doesn't matter at the end of the day. This is all in all. So this actually a screenshot highlights the communication that a government of a one specific country is doing with other countries. But you can imagine the kind of, the decision-making process that particular governments are doing, and that is all revealed on the internet. That is all some attackers are using that. So before they do anything, these guys have the information that what exactly we need to do. And they actually go really ballistic and then actually go after launching other set of attacks. Or maybe if information is stolen, then they have all the capability to make smarter decisions. So it could impact greatly to the businesses of the organization, not only government ones, but also the specific critical infrastructure ones as well. So here I'm actually highlighting the live recording of WebEx, which is again from a compromised system that's specific to a one government organization. So I actually removed all that data, highlighting the pictures who were a part of that, but you can clearly see the countries that are involved. And it's all kind of information, and I would say data that is extracted out of those compromised systems. So my question in this case, which I always ask myself and want to ask the community as well, we believe that we have enough defenses in place, but if that's the case, why all these things are happening, right? I mean, we have so many fantastic security solutions in place that they are already helping, no doubt in that, but still attackers find a way to actually some other loopholes to go ahead and get this kind of data. You can imagine if your decision-making process is being leaked before exactly decision being made. So how impactful it can be for the organization and the governments, right? But it's all happening, and it's one of the biggest problems that the world is facing. So right now, if I just a little bit reiterate, we talk about why data is important, the perspective in this present world. We've gone through the advanced threats, why we need to call them digital weapons. We've gone through the layout of targeted cyber attacks in the context of phishing, talking about tier 1, tier 2, and tier 3 attacks. We then talk about Locky botnet and also info stealer. Right now, we also need to look into the cloud infrastructure, right? I mean, it cannot be remain unimpacted in the sense, right? Like attackers are not targeting this cloud infrastructure. That is not the case. Cloud is being abused left, right, or I would say north, south, east, and west. It's all across. So let's take a few examples and the real world case studies to look into how critical this state is. So here I'm actually presenting the TND Kubernetes, exploit and attack model. What we really need to understand here is that how exactly the attackers went after exploiting the kubectl command, and then exactly going from there into different nodes, which contains different pods, right? So they went through that utility because it has like exposed service, and they just completely went into the cloud infrastructure, manipulating the orchestration framework. In this case is Kubernetes. So once you actually get a control of the pod, which is like running multiple nodes in a cluster, and then you can actually utilize it for nefarious purposes. So what we saw in this case is that, vulnerability is exploited, or maybe a configuration bug was exploited. They went in, they figured it out running clusters in Kubernetes. And of course, nodes were there, but then they able to compromise a couple of pods in it. Once that is done, they abuse it for crypto mining operations. So as a part of our research, we were analyzing this attack. Many other security researchers looked into it as well. So what came to our surprise is that how these attackers actually utilize NVIDIA drivers to do that. So they have these Kubernetes, root payload scripts that are fetched from the remote location. So if you look at this particular screenshot, it's like fetching the shell files, because of course, if the pod is compromised, usually the outbound communication, which we call as the egress communication, are pretty open, right? So because you need to use it for updates, patching packages, and sort of other things. But if one attacker is able to find it out and compromise the pod, it is also possible they have utilized that kind of configuration to abuse it. And that's how it happens. So once the pod is compromised, you can fetch these kind of Kubernetes root payload. That's what attacker did. And if you look at the shell script, it has like everything that is needed to actually fetch more NVIDIA drivers and then do it. And why that is the case? Because if you look into the cloud infrastructure, anything that gets compromised, let's say in this case is a pod, they are able to extract the underlying system information, like whether this particular cloud infrastructure is supporting any kind of specific configuration, which allows them to run heavy and robust NVIDIA drivers. And when they figured it out, they thought like, okay, that's the case. Now let's just fetch NVIDIA drivers and then transform into a crypto mining operation, because then you can harness the power of underlying infrastructure. But you can see that apart from that, they're going to exploit it. Of course, they're going to extract a lot of data out of it, but the amount of cost that is going to incur to the organization in this case, right? Because their systems are running day and night. Maybe they can use, sleep mode where they can actually do it little bit, step by step, but that depends on the artifacts. We analyzed that and we were able to figure it out, like how they're actually utilizing the Google Cloud for this kind of operations as well. And all what we are highlighting here is actually how they actually did the whole purpose of fetching NVIDIA driver, installing them, running on the compromised pods, and then let the crypto mining operations keep on going on. And it's just not only the crypto mining operations, but it is also more related to other infections, like using cloud infrastructure, again, for launching new set of attacks. But this is all happening in the real world. And what we are highlighting is not apart from the one set of malware, but it is like different set of malicious code that is being utilized depending on the infrastructure. So now, this is another most important research that we are doing in recent times. I don't know, when you have opened up, browsers, media outlets, you have seen that thousands and thousands of cloud databases are compromised, right? And that is another biggest, threat vector these days. And I want to highlight a little bit more in this space. Like a couple of years back, when we build applications, we talk about tier 1, tier 2, and tier 3 applications, right? And in that case, like specifically the application architecture. Tier 3, we talk about how the databases are being deployed. Right now, in this present world, we talk about microservices-based architecture, where applications are much more on demand. But the more important aspect that we really need to look into is, again, the databases, because that's where data is stored. Very simple thing, right? So why not the attackers gonna go after these databases, whether they are standalone systems or that they are deployed as a service, right? DBaaS. So in this case, what we have seen that, of course, this problem popping up, and as a researcher, what we really need to do in this context. So what we did, we definitely analyzed the real world systems. In this case, we started with that Elasticsearch instances. And you've exposed one, so we did extensive amount of time being spent in this case. But we figured out like the patterns, how these systems are like Elasticsearch databases are being impacted with ransomware, right? So you have like proper API interface, HTTP1, Elasticsearch. You go through, you can search through indexes and all that, right? And we also extended that research in the case of MongoDB. As you know, in MongoDB, we have collections. Collections are iterative in nature, and then databases are structured. You have collections in that, and you store data accordingly. So we focus most of these scenarios where like included Elasticsearch instances and MongoDB one. And this example actually highlights how when it is infected with ransomware, what kind of ransom messages are being displayed. If you scan through the whole indices and you scan through the collections in MongoDB. And that's how it looks like. But as a researcher, we don't want to stop here. Like the question that we ask ourselves is, what exactly we really need to do? Like these infections are happening. We did a detailed study. We built the threat intelligence modules on that. So the question that we need to solve here is that, can we build a certain set of tools in this case, where we can actually highlight that, this kind of tools have capability to kind of detect infections in Elasticsearch and MongoDB. And we did the same. So the very first tool we designed in this case was Straffer. It was a tool written in Python. It basically automates the whole intelligence that we gather during the research, detecting Elasticsearch instances infected with ransomware. It's all available on the internet, GitHub, you can fetch it. So the tool actually highlights against a real world IP. It's not active anymore right now, but you can see that how it actually goes through every single indices in that, and then actually able to detect it, where the ransom message is and what it's all about. So the tools have different modules. You can do a basic scan, and then you can also do an intrusive scan, but it's all automated for the audience to do more research. Similarly, we built another tool called as Zenflot. This has the capability to detect ransomware infections in MongoDB instances. Again, it's in a live, run against live target. You can see how exactly detected, support different kind of modules. So the part of doing all this research and you share it with the community is that they can utilize this research, and then when they are building components in the cloud infrastructure, they can actually utilize these tools as a part of their agile testing or other testing procedure. At least they can use that, a kind of intelligence that has been shared via these tools to go ahead and make sure the databases that you deploy in your cloud infrastructure remain secure. Rather than doing it later on, it could be a part of penetration testing or vulnerability assessment scenarios as well. But rather than it could be done right away during the deployment, whether you follow shift right or shift left approaches, it all depends. But you can do that and utilize other security researchers' work to make sure they do it. Again, the question is, why this? As I mentioned, data resides in databases. So we want to make sure any component where data is being stored, we need to ensure that those are secure. But these tools are available. You can check online, utilize the code, and then do it really good with it. So right now we cover different variations, the way cyber attacks are happening, whether it's cloud, whether they design botnets, remote administration toolkits, and the kind of data they store. So we recently did another interesting research when the recent nation-state conflict that was happening. I don't want to go which entities are involved. We all know, but we generalized the aspect of it, how dangerous it could be into the internet space when attackers went haywire, whether it's from a one nation state or the other nation state, or from the global nation states. But here's the thing we really need to understand in the context of data, what exactly was that? So when we were analyzing all those things, different kind of things that got leaked on the internet, whether it's the Gazprom documents, which I'll show you a couple of them as well. But how we really need to sketch a model around it, that's the most important part. You could have said, oh, they actually distributed malicious code, which has the capability to actually make the system go useless. Yeah, it's okay, but what is the whole model around it, right? If we really need to build threat models, we really need to understand the attack model. And of course, you can transform that into an impact model as well, how it's going to impact. And that's what we are going to talk today in this context. So again, I will reiterate it. So because it's a really different concept in the context of cyber wars, I've been using the term digital weapons, but again, I'm gonna talk a little bit more about it with different context. As I mentioned earlier, they really went ahead and go for subverting the integrity of the compromised systems. But right now, there are other characteristics in this case as well, disrupting economic functions, right? Production, consumption, and growth by targeting those systems. Well, for example, if we talk about, critical infrastructure systems, web HMIs, SCADA systems, and all that, they can even go after that, which also involves, if we extend that definition, the critical infrastructure, it includes banking systems, financial institutions, civil liberty, websites, and many more, of course, including military and government organizations as well. Another target in this case is to impact the network availability, which is an important part, which also have an indirect relevance to how they, impact the data. Because your systems go useless, there's no point of extracting data. They just simply disrupt the state of, existing data components. And of course, and if they all go pretty well, they really want to go after intellectual property in that case, which all falls into the data exfiltration, data stealing, data hijacking. And then, okay, I want the intellectual property. I want more information about whether critical infrastructure system is still alive or not. So when I say this statement, what exactly I mean by it? Cameras, network cameras, right? And that are connected to the internet, or if you have compromised a certain system and having an access from that system to those critical cameras and seeing whether the critical system or infrastructure, how they are operating. We'll take a look at it and you'll get a feel of it, what I'm talking about. But here, what I'm presenting right now here is a proper model of understanding digital wars, specifically in the context of data. So when they go after, they have different things to choose from, right? It could be data destruction, as I mentioned. They sabotage the systems, they make the data useless, completely ineffective in nature. I don't want the data, I just want the systems to be completely impacted. Then they can also think about data exfiltration, like why not? I mean, if I'm into the system, let's just extract the data. It could be intellectual property, critical data, we'll talk more about it a little later, but I show you the examples of that in the real world. And of course, denial of service. Just impact the network till we figure it out how we are going to compromise the system. Let's just keep impacting the availability. So when I talk about the availability in that concept, we know when everybody goes through the course for computer engineering and even the basics of security, CIA model, right? Confidentiality, integrity, and availability. So it's a broad and holistic concept if you look at it, and it can everything can fall back into it if you put proper pictures and proper boxes into it, explaining what it is all about. So in this case, it is availability. I'm going to impact the availability. Systems will not be available. It's going to serve my purpose. And that's what we have seen in that nation-state cyber conflict as well. So let's take a look into the data destruction, the model that we had discussed, like kind of digital weapon being used in that space, right? So in this case, it's called Whispergate. You might have already seen it, but we also try to look into it. We saw that, how it is rewriting the boot record, right? So what happened in that is this malware has a capability to install itself into the system, of course, but it is designed in such a way that it can actually manipulate the kernel level drivers. Because then, let's say, for example, Windows operating system, if you really need to tamper the boot processes and all that, you need to have that kind of privilege, or you find out another exploit way to transform the code from a user land into the kernel land so that you can actually manipulate the boot record. And that's what they did. They simply made it corrupted. So they just triggered the reboot command. Every time the command was triggered, system was not able to, boot properly, and it just go into a state where it cannot be taken back. But it was a part of the data destruction process that what we have seen. That is also called as an infection. So in this part, we have seen how Discord has also been used. We have earlier seen that, where Discord CDNs are heavily used for specific type of attacks. They come up with the CDN, then they, actually put up some kind of malicious script in there. And because these CDN and everything is included into web pages through JavaScript links, and then they fetch these scripts and render in a browser to do different kind of activities, maybe, just, exploiting some kind of thing in the browser, component libraries, or just finding one or the other way to get into the system. But even in this case, what we have found that the Whispergate malware, again, I'll use the digital weapon, they actually distributed it wide, this called CDN as one of the infection vector. So you can clearly see like all these technologies, whether the new world messaging systems like Discord, Telegram, in the backend supporting infrastructure they have like CDNs and how this are being abused. And then they actually use it like a JPEG, some sort of steganography and all that thing in certain variants. And when you actually fetch that thing into the code and how the CDNs like push that code outside, it's starting getting infected, targeted against the specific systems on the internet. And again, the caution here is that, they can do wiping, they can do other things. So we talk about making the system completely useless. We talk about the infections where they are like wiping code and, just, making certain files on the system go useless, which are critical in nature and things like that. But that was a real part. So again, now in the model, we talk about data exfiltration. So this is the samples we took from some exfiltrated data. I don't want to go too much detail into it, but I want to give you the glimpse of it, what was leaked during that time. So this is the kind of blueprints for us, several power and energy corporations, right? So if nation state cyber conflict is happening in addition to the real world conflict, it's all about energy and power at the end of the day. But you can clearly see, these documents, right? I mean, they contain so much information that it's just even hard for us to actually analyze it. But we put up in this case to highlight what is exactly happening in the backend. So we talk about intellectual property. I mean, I don't know whether it's really secure or not, right? But we have seen this kind of data being distributed in the underground cyberspace, which we discussed earlier as well. Another example of the data exfiltration. So these are the blueprints typically highlighting how a big and a critical infrastructure works. So this is much more related to the electric systems and the power systems that were running in one of the nation state. But it was all leaked as a part of the cyber attacks, right? Because of SCADA systems and critical systems were compromised. And this is just a tip of the iceberg, what I'm showing you right now. There's a much more to it, but it is very critical. And I don't think so. Even it's like, as I mentioned earlier, it's very tough to analyze these kind of documents in a short period of time. But it's all happening. This is the world of cyber world, if you ask me. And at the end of the day, we use technology, but how it is being abused day and night, we're exactly presenting in front of you, how exactly it is being done. Another example of the data exfiltration. So I have put up the things, but you can clearly get an idea. And the point that I mentioned, and we discussed earlier as well, like why exactly it is important during these nation state cyber conflicts or the real world conflicts to get an idea about how your critical system is operating. So these screenshots are taken from the compromised cameras, and which actually stores these screenshots into the local systems, which actually got compromised as well. So once the system is compromised, you can get a data from there, or those network devices are storing their data onto the compromised system. But I'm just highlighting the impact of this stage. You can clearly see how these, I think it's from the Gazprom primarily, some of their infrastructure, and you can clearly see how these things are being, structured, running in the remote locations on the globe, but you can still figure it out somewhere sitting in a remote location, and you have all that information. This is the impact of cyber wars. This is the impact of how data is extracted out. And it is very problematic, but at the same time, you can clearly see how good the infrastructure looks like, right? And another screenshot in this one is very critical. So just imagine, I'm extending this threat model to the next level. If you're able to get a screenshot of these cars that are parked there, with you have all these kind of their numbers and VIN numbers, you can clearly figure it out by checking those numbers somewhere, some point of time, where it actually belongs to. And you can have more information starting from the one compromised system, and you can see where you actually go through. It's all happening. It's very problematic, and it's very critical in nature. And again, I took these screenshots from the NetBlocks, a great website, to actually analyze how the data, basically the network connectivity goes. And it's fall into the category of impacting availability. That is denial of service attacks. NetBlocks, like how the specific regions during that time were impacted and completely taken off the internet, and how it impacts the state. Even actually, if your internet goes down for like 5 minutes, 10 minutes, it has a great impact, right? Communication is broken, and economic functions are also broken to a great extent. But this is a model that is a very important in the context of when we talk about data destruction, data exfiltration, and then denial of service, impacting availability at the core. But that's the world that we live in, and it's happening all across. So in the conclusion, in the context of nation-state cyber conflicts and cyber wars, so it is very important to defend nation-state cyber space against targeted attacks using digital value. They are actually utilizing digital weapons, but the defending is really required right now. Whether a community can come together, build some tools that can be utilized, organization need to enhance their code. But exactly at the end of it, this is the need of the hour. And what I've simply showed you during this presentation is just not only a 2%. It's just basically a 2%, I would say. It's like 98% is still sitting somewhere, hidden somewhere. But you can still see the impact of this research and why it is needed, and why people like us to actually do this kind of research to educate audience and educate ourselves as well. And we might be thinking the world is like, oh, this is not happening in the world, the global world right now, but it's all happening. And it's the need of the hour. So in conclusion, in this research, what we have realized during this, in the last 1 year, which we are spending this research, is like, future belongs to those who own the data. It's a very simple thing. It's not about you control it. We can't even control our own data, right? I mean, look at what we have seen during this research. So much of the transactions are happening, billions and trillions, number of transactions that are happening every month. I mean, and the problem is that how much from the authorization boundary concept, how much data is going out of the authorization boundary, and what is the visibility that we have in that space, right? So, as I said, it's not only true for the attackers, it's also true for the organizations as well. Whoever gonna have more data, they are going to build more robust solutions. And the last point that I want to make during this research and in conclusion in this case is that adversaries are building advanced digital weapons to launch attacks, which is happening all across. So the security community should respond at the same level. So we have to up our sleeves as well and build more robust security prevention and detection solutions and use intelligence to the greater level. And in the last part, I say, we all believe that error is human, human are prone to errors. So we really need to make sure how we can reduce our mistakes in that and just have a little bit more proactive approach to our own data and making sure that if we can actually use a little bit of semi-air gap concept of systems where we exactly hold the data to specific systems and not to use one system as overall. I think it helps a lot. With that, I hope this research has some impact and you might have enjoyed it. As I said, much more to it. Maybe next time. Thanks, everyone, and thanks for attending this talk. Thank you very much. Any questions or queries? All right. Thanks, everyone. Thanks for your time.